Good morning, viewers. Today the second class for work done power energy second class, second video. Work power energy, work power energy. In this we discuss in the previous class we discussed about work done. Today we continue about work done. Now in the previous class we derived the relation for work done. Work done W equal to F bar dot S bar. This we can write as Fs cos theta. This is the first formula. Let it be. This is another formula. W equal to F bar dot S bar. W equal to Fs cos theta. Now what are the how many types of work done? Or what are the first of all write the units of work done. Now write the units of work done. Units of work done. Units of work done. How do you write units of work done? First of all, take the formula. From the formula we can derive the units. Take the formula. So for work done, what is the formula? W equal to F bar dot S bar, or take the second formula. W equal to Fs cos theta. Now for theta equal to 0 degree. Theta equal to 0 degree means cos theta equal to cos 0 degree, that equal to cos 0 means 1. Now substitute this value in relation to what happens? Substituting theta equal to 0 degree in relation to, then equation 2 becomes what happens? See, W equal to Fs into cos theta means cos 0 means 1. Cos 0 equal to 1. So Fs into 1. So W equal to Fs. So in this case we can write F is positive. S is also positive. Means F means force. Force is a vector quantity. S is displacement. Displacement is also a vector quantity. Here force is positive, displacement is also positive. So both force and displacement are positive. So work done is positive. Right? We can write W equal to F means plus F. S means plus S. So we can write plus Fs. So here this is about Fs, it becomes work done. So plus. So in this case, if theta equal to 0 degree, W equal to Fs means positive. Take theta equal to acute angle. So in this case, work done is positive. In this case, work done is positive. Work done is positive. So go to the first quadrant. What about first quadrant? I am considering I am taking a two-dimensional plane. So x-axis, y-axis. Now what happens here? The angle between the x-axis and y-axis means in the first quadrant. What is the angle between these two? This is 0 degree. This is 90 degree. So I am considering this angle between 0 and 90 degree. So this is acute angle. So acute angle. So theta less than 90 degree and 0. This is the first quadrant. So now in this case what happens? W equal to Fs. W equal to Fs. So here let it be here F is positive, SC is positive. So for here between if the angle is angle between the force and displacement is acute angle, that means between 0 degrees and 0 or 0 theta equal to 0 or more than 0 and less than 90 degree, then what about work done? Now work done is positive. So in this case work is positive. Second case 2. Case 2. What about case 2? Suppose F is acting along horizontal direction towards positive x-axis. Positive x-axis means F is acting towards the right side and S is acting opposite side, negative x-axis. So means what happens here? This is left side. Take it. See here. In this second case, force and displacement exactly opposite direction. But these two are parallel. Suppose I am taking this, I am considering. Suppose see I am taking force and displacement are exactly opposite to each other. Exactly opposite to each other. Opposite to each other. So what happens? One is positive, another one is negative. So here let it be force is positive. Automatically displacement is negative. Displacement is negative. Now substitute in this case. So F W equal to plus F into minus S equal to plus into minus. So minus Fs. So work is negative. Minus you got here. We can express in other words also. Take W equal to second model. See, take this formula from second relation. From second equation. W equal to Fs cos theta. W equal to Fs cos theta. See, in this case, both are opposite to each other means angle between force and displacement is 180 degree. So theta equal to 180 degree. Now, since F bar S bar are opposite to each other, then work done W equal to Fs into cos theta means cos 180. Fs into cos 180 degree. Cos 180 means minus 1 equal to minus Fs into minus 1 equal to minus Fs. So we can write like this also. So W equal to minus Fs. Okay, like this also you can write W equal to minus Fs. This is also we can use this model by using this relation W equal to Fs cos theta. We can get W equal to minus Fs means Fs means work done, W equal to negative. So work done is negative in this case. Work done is negative. See, once again I am explaining. For work done, W equal to F bar dot S bar we can write, we can take. But from the relation A bar dot B bar equal to AB cos theta we can take. So this we can write A W equal to F bar dot S bar equal to, by using this relation, since A bar dot B bar equal to AB cos theta, so W equal to Fs cos theta. This consider this as a second relation. Okay, now this is about units of work done. I will explain. Now take cases. After completion of this, I will explain the units. Okay. Now there are three types of work done. So work done three types. Three types of work done. Three types of work done. Three types of work done. One is positive. So here what is positive work done? So here positive work done. First one positive work done. Second one negative work done. Okay. So three types of work done. So this is a case one positive work done. Positive work. Positive. Case one is positive work. So this case one. So case two negative. Negative work done. Case two is negative. Case two is right like this. Okay. Case one. So when work is positive between 0 degrees, if theta is acute angle, then work done is positive. If theta is acute angle, then work done is positive. If theta is at 180 degree, then force and displacement are exactly opposite to each other. So W equal one is plus quantity, and the one is negative quantity. So you can take W equal minus Fs. So negative work. So this is negative work. Second model. In this case, second model, you can take 180 degree by substituting theta equal to 180 degree. So you can get work done is V2. So once again, this is the example of positive work done. I am taking theta equal to 0 degree. So we know the cos theta equal to cos 0 equal to 1. So I am explaining this work done by taking 0 degrees. W equal to Fs. Why I am taking theta equal to 0 degrees means okay, now a block is here. This is a block. Now where is this block? This is on a table or on a ground, whatever it may be. Okay, now it is at a rest position. Rest position means velocity u equal to 0. So what about velocity? Velocity equal to u equal to 0. Now let this position equal to, let the position of the block equal to A. So what is this called? Initial position. What is this called? Initial position. Okay. Okay. Now I am applying some force in this direction. Since force is a vector quantity, it has direction. It has both magnitude and direction. Now what I am taking here, a block is at the position A on a plane surface. Now which is at rest. Now I am applying some force on the block so that its position will be changed due to the change, and let it be reaches to the position B. So what is this one? This is the final position. This is the final position. Okay now. So this is initial position, this is final position. Now what is the final position minus the initial position gives? It gives about the displacement. So yes, so this is the displacement made by the body from when it moves, it displaces from position A to position B. So due to the application of force F bar, there arises a displacement S bar. So at this we can say that this block has done some work that equal to W. Okay. Now due to the, once again I am explaining, a block is there or an object is there, a car is there, whatever it may be. It is at position A. Initially it is at rest. Now I am applying some force on the block towards the right side. Now, due to the force, this position of the block changed from position A to position B. Now, what we call A is called initial position, B is called final position. Okay. Now, according to the definition of displacement, final position minus initial position gives the displacement. So, the displacement is denoted by S bar. Now, force into displacement equal to work done. So work is done by whom? Work is done by the block. Okay na? Now here what which direction the you are applying force? Right side along horizontal direction. Here what about the displacement? Displacement is also along horizontal direction. Both are parallel. So F bar and S bar are parallel to each other. In this case, we can take theta equal to 0. Okay. Now means force and displacement are horizontal along the same direction, are parallel to each other. So angle between the force and displacement is nothing but 0, is equal to 0. So I am taking theta equal to 0. So cos theta equal to cos 0 equal to 1. We can use this one. Okay. Now take this formula. Equation 2 becomes, what about equation 2? W equal to Fs cos theta. W equal to Fs cos theta means W equal to Fs cos theta. Already we found here, we have found here theta cos theta equal to cos 0 equal to 1. So directly I am substituting here cos theta as 1. So W equal to Fs into 1, W equal to Fs. But F into S is nothing but work done. So work is positive in this case. What about second case? Also in if theta is acute angle, means theta is the angle between the force, let it be the force, let it be the displacement. So here, if theta is the angle between the force and the displacement. Now if theta is acute angle, if theta is the acute angle, now then automatically work done is positive by using this relation. You can take the value of theta between 0 degrees centigrade and 90 degrees. You can get positive only. F positive, S positive. So W equal to plus F plus S. So totally Fs positive. So work is positive in the first case. But that means angle theta is acute angle. So case 2, come to the case 2. F, S are exactly opposite to each other. That means if you are applying some force along horizontal direction towards right side, but object moves opposite to each other. So what about this two? Here angle between these two equal to 180 degree. So we can take this. Means an object is moving this side. So angle between these, one is force, another one is displacement. So angle between these two equal to 180 degree. So by substituting W equal to Fs cos theta, Fs cos 180, cos 180 equal to minus 1. Therefore W equal to minus Fs. So what is negative. You can do by do the problems by taking this second model, or you can write directly from the definition W equal to plus Fs minus S plus. So minus Fs negative. This is negative one. So work done is positive in first case, work done is negative in second case. Work done is negative. Hold on. Copy this one, pause it and copy it. We will continue.